In example 5 here, we are looking at a binomial probability problem. Again, increasingly children in society are being raised by their grandparents. According to a random sample, 28% of grandparents are raising their grandchildren. 25 are randomly chosen and considered. What's the probability that exactly 7 of the 25 grandparents are raising their grandchildren? Probability that more than one, and probability that 1 to 3. So this is binomial because they either are or they are not raising their grandchildren. So we can use binomial CDF to compute these probabilities. So the 28%, that is our P, probability of a success, so 0.28. We selected 25 total, so N is 25. And then in this first one, we're looking at exactly 7. So we want to know the probability that exactly 7 are raising their grandchildren. So remember when you have an equal probability, use binomial PDF. So we want to do binom PDF. And then remember the syntax is N, P, and X. So 25 is our N, P is 0.28. and X is equal to 7. So let's enter that on the calculator. So second variables takes us to the distribution menu. Scroll down to PDF. Trials are 25, P 0.28, and X is 7. Paste it, enter 0.1754. And then probability that more than 1, so that would be probability that X is greater than 1. And remember that binomial CDF only gives less than equal probabilities, so we need to write this in terms of less than equal. So we'll look at the opposite probability, so 100% or 1 minus the probability that X is less than equal 1. So greater than 1 would be 2, 3, 4, 5 up to 25. Less than equal 1 is 0 and 1. Subtract that from 100%. So this will be 1 minus binom CDF. C, because we're doing cumulative, less than equal probability. N is still 25. P is 0.28. But then it's less than equal 1. Let's enter that on the calculator. So we got 1 minus, go to the distribution menu, scroll down to CDF, option B. 25.28 are the same, we just need to change that 7 to a 1, paste it, enter 0.9974 to 4 decimal places. So 99.74% chance that at least one set of grandparents is raising their grandchildren. And then 1 to 3, so that would be 1, 2, or 3. So this is probability 1 less than equal X, less than equal 3. So, and this is 1, 2, or 3. So we want to write this in terms of less than equal probabilities, like we did here. Equal or less than equal. So we could do probability of 1 with PDF, and then probability of 2, and then probability of 3, and then add them together. So do 3 of these. That's one way to do it. Or we could do less than equal probabilities. We could do probability that X is less than equal 3. So that would be 0, 1, 2, or 3. And then we could subtract off. Let's see, we want to include 1. All we don't want to include is 0. So probability that X is equal to 0. So that would be another way to do it. So less than equal, that's going to be binomial CDF. So binom CDF. 25 is our total. 0.28 again. And X is equal 3, less than equal 3. And then for the probability X equals 0, That's an equal, so we'll use binomial PDF. PDF for equal, CDF for less than equal. 25.28 and 0. So let's go ahead and enter that in the calculator. So second variables, go into our distribution menu, binom CDF. Let's see, 25.28 and 3. Paste it, minus second variables, and then go down to binom PDF, 25.28 and 0. Paste it. That is what we wanted. Enter. Oh, okay. What happened here? So, we got 2 minus signs. Second, enter. Scroll back and get rid of one of those minus signs. Delete. There we go. So 0516. So 5.16 chance that 1, 2, or 3 of the grandparents, of the 25 sets of grandparents, are raising their grandchildren. So just be aware of some of these keys here to identifying binomial. We're given a percentage here. 28% of grandparents are raising their grandchildren, and then think about, okay, how many outcomes are there to that experiment? Well, either they are or they aren't. Only 2 outcomes. That's your clue. We're using binomial probabilities.